at a microscopic level keep vibrating, keep translating, keep oscillating back and forth. They have thermal energy. You can see the ones in the red have more thermal energy, they have more vibrations. The ones in blue are a little bit colder, they have less thermal energy. And we are going to talk about energies a lot, and specifically transfer of energy, which is heat and work and so many other things. And of course, we have our special guest Pandu also coming today. So let's begin with me, Shreyas, your master teacher for physics at Vedantu. I hope all you minions are doing fine. Hello Aishwarya, Kirito, Dhanush, Vikram, Vasudevan, Uncharted, Science Priya, Yalini, VK, welcome. Albert, hello Ankit. Good evening. So guys, I really hope today morning whenever I conducted my session, you have seen at least the replay of that, the KVPY essay discussion session, a very important session. I hope you'll watch it. By the way, I'm little bit angry on you minions because you have missed that session, many of you. I know many of you probably also had schools, but you should definitely watch the replay. Yes? Okay, cool. I'm very good, Albert. No problem. So I've answered all your queries also on the chats, in the comments. Hello, Hridaya. Oh, okay, Dhanush, you didn't give KVPR. Next year, you should definitely give it. All right. Albert, if you have got 59 in essay, that's decent. In SX, also, it's okay. It's dicey. Let's see what happens. In SX, I think it might be slightly on the lesser side, but let's hope for the best. I don't know. Good evening, VK. Yes. So next year you need to give it. Hello Arant, hello Nadwa, or many new people out here. And before we begin, I hope you guys follow me on Instagram. That's my Instagram handle, Shreyas_Vedantu. Go ahead, check it out. Follow me, tag me in different posts, and I would love to see what you guys do. And I'm pretty sure you too will love what I do in my daily life. All right. Having said that, I hope you have already smashed that like button. Go smash that like button. Yes, you need to give me that energy. It's a long session. So show me some love. Show me all that support. And all the new minions out here, go hit the subscribe button. That's the only way you can be called as a minion or a V enthusiast. Go hit that button. It's free, of course, by the way. Yes. Okay. Hello, Soumya. Yes, no snacks, but the thing is, I remember I told you guys, I'm not going to eat too much, so only water for me today. So I'm not sure what you guys have bought for today's marathon session. And tomorrow it's going to be a PYQ series mock test. So I'm going to give you a test paper beforehand. You're going to solve it, and we're going to discuss that paper tomorrow at 7 o'clock. Remember, all these classes are scheduled at 7 o'clock. In case you have missed any of these classes, feel free to check out our playlist and past videos. Now, let's begin with our session. Previously, I have talked about heat. What is heat? Heat is not the energy which is contained in a body. No, heat is the energy which flows from one body to the other. And heat always flows from the hotter body to the colder body. That's what we have seen. All right. Remember, I have talked about this during heat transfer. So heat is the energy in transit which flows from hot body to cold body. Only that flowing energy is called as heat. Once it is contained, it is not called as heat. Remember that. Now, what is the sign convention of heat? That is what is very important. All right. That is what is very important. Now, if you have a system, let's say there is some stove that you're preparing some snacks, I don't know, you're preparing some food. So let's say that is my system, for example. All right. So let's say you are making, I don't know, on this, maybe you're making vada pav. All right. So somebody is making vada pav. So this is my system. All right. Now, if my system, all right, if it absorbs heat, it takes in that heat, then the heat is said to be positive. All right. If it releases heat, it gives away the heat is assumed to be negative. And remember, heat absorbed or released is given by this formula, mc delta T Please keep in mind, C will depend on the process. So this will definitely depend on the process, whether it is isochoric, isobaric, isothermal, etc. So that's why the heat will depend on the process even for the same change in temperature. Yes, keep this in mind. For the same temperature change, the value of C will be different and even value of Q will be different. Keep this in mind. This is for masses. If you don't like masses, if it's for gas, then you can also have N, which is number of moles. So this N is moles, this M is mass, and this C accordingly will be either molar specific heat capacity or just specific heat capacity. If it's moles, it will be molar specific heat. If it is mass, then it will be just specific heat capacity. I hope you know this. All right, cool. Let's get going. Keep this sign convention in mind, and I am pretty sure you remember this formula from our previous discussions. Let's get going to the next part. Now, when I talk about internal energy, so let's say I talk about Pandu. Pandu has some internal energy. Now, Pandu has two kinds of internal energy. One is its own potential energy, and second is the kinetic energy. Yes, remember this. The total internal energy is basically the sum of potential and kinetic energies. Similarly, even gases have two kinds of energies. One is the potential, because of their masses, charges, etc. They have some potential energy. And kinetic energy, because they are in the constant state of random motion. Alright, so that is the total internal energy of a gas. But if you remember correctly, alright, from kinetic theory of gases, you will remember that you generally neglect the molecular forces of attraction or repulsion. Even in gas laws, remember the ideal gas equation, when it is talked about, the molecular forces are neglected. That means the potential energy is neglected in most of the cases. Keep this in mind. Now, having said that, so remember this, the internal energy being the sum of kinetic and potential energy for an ideal gas. For an ideal gas, this is very important. The potential energy is neglected. It's fair assumption. All right. So this is something which you should know. And the symbol for internal energy is U. So change is delta U. Keep this in mind. So delta U strictly is delta PE plus delta KE. But this is in general. But for an ideal gas, it is only delta KE for an ideal gas. Remember that, because the potential energy is not to be accounted for. Keep this in mind. All right, very, very important formula. I hope this is clear. Is that understood, everyone? Yes, minions, what say? I hope you guys have understood this. Very, very important assumptions. I hope you are also making notes of all this. Wow, when I come DK, nice. I like that word, using wanna come. Sounds very traditional and very Indian. What do you guys say? Very good, Dhanush. Yosh. Yes, amazing go. Now, one more thing. Delta U, okay, for an ideal gas is always NCV delta T for all processes. For all processes, this symbol stands for all. Okay, that's a symbolic representation. No matter which process you take, it is NCV. CV is specific heat capacity at constant volume. Keep this in mind. And remember, CV's value is R upon gamma minus 1, where gamma is the ratio of CP by CV. Alright, so you should remember this formula. NCV delta T for ideal gas, and that you should know for whom it is. Ideal gas for any process. Keep this in mind. Alright. Very good. Let's get going to the next part. And you can see this simulation clearly showing how the internal energy is different and how the temperature is different. More the internal energy, more the temperature. And you can see internal energy is the sum of kinetic and potential, but usually we neglect potential for ideal gas. Next up is work done. All right, next up is work done. Now, what is work? Work is force into displacement. But in gases or in thermodynamics, we generally don't talk about forces. Instead of force, we talk about pressure. And instead of displacement, we talk about volumes. Okay, so volume of the system, pressure of the system, etc. Like you can see, there is a cylinder, there is a piston. That piston can move inside and out. And here there is some gas which is trapped. So that gas can do work, all right, when it is pushing that rod away. And when that rod is coming this side, left side, towards your left side, that time the work is done on the gas. So when the gas expands, the gas does work, and when the gas contracts, then the work is done on the gas. Now here is the catch, and here is the differentiation part where between physics and chemistry. So keep this in mind. Very, very important stuff out here. So work is basically positive, all right, in expansion. Keep this in mind. In expansion, it is positive, and work is negative in contraction. Okay, and whenever we talk about work, it is always the work done by the system, not on the system. So in chemistry, instead of by, the word used is on. So you need to be little bit careful. So the signs only change for work, otherwise everything is same. Also keep in mind that in that 3 hours of examination, you have to solve physics as well as chemistry paper. That means you need to switch over the sign conventions from physics to chemistry. So don't ask me why that is so, but that's how it is. Let's just follow. I hope you minions have understood it. All right, cool. Yes, so keep this in mind. And then comes the formula for work done. I hope everybody is clear about this. Now let's see the formula for work done. This was the sign convention. So the formula for the work done. Okay, so here it is. The work done formula is integration of P dV from initial volume to final volume. So this is the formula which you should remember. Keep this in mind. Okay, this is the formula. Now, if you notice there is integration, the moment there is integration, it should strike your mind. Yes, it would involve area under the graph. But which area? There is pressure and volume. That means pressure will be on the y-axis, volume will be on the x-axis. So the area under pressure versus volume graph. So this one, okay. So area under pressure versus volume graph gives you the work done. Keep this in mind. So the area under it. So that's an easy way, but graphically keep this in mind. Now you might be wondering, sir, how do I decide when is work positive and when is work negative? Then it will probably strike your mind, oh, I know what to do. When the graph goes below, then it is negative. The area is negative. Wrong. First of all, the graph can't come here, here, here. No, because volume or pressure can't be negative. So how can it come in other quadrants? So keep this in mind. Very important stuff. So if you have, okay, this is volume, this is pressure, the graph cannot come in any of these three quadrants except for this first quadrant. Then you will be like, okay, now this is a line and let's say this is the area. How do I decide whether it is positive or negative? Very simple. Just check the arrow mark, guys. Yes, just check the arrow mark. If the arrow mark is like this, what does it mean? Initial volume, final volume. Volume has increased. Check the final volume. Is it more? Yes. Then the work done is positive. And then if the arrow mark is like this, then think about it. Final volume is less than the initial volume. So the work done is negative. That's how the sign convention works for PV graphs. No problem, Shreya, just join in. And all those minions who are joining in a little bit late, don't worry. Just rewind back. Even in a live class, you can rewind back. That's the advantage of these YouTube live classes. And you can catch up at 2x speed also. and you can pause anywhere you feel like and come back to the same state where we are. All right, very good Devika, very good Dhanush, Sorana. Hello, welcome all the new minions. Very good Nadwa, very good. Amazing. So keeping this in mind, let's go ahead with the next stuff. Now, how many of you know this cartoon character? How many of you know this? How many of you have seen this cartoon character? Well, probably this will remind you of your old childhood days. Yes, there you go, Dhanush. BD Krito, yes, Science Priya. Popeye the Sailor Man. I'm Popeye the Sailor Man. Yes, that's it. Very good. Now, here's our system. And we are going to explain first law of thermodynamics. Yes. All right. So, here's our system and we are going to explain first law using Popeye the Sailor Man. He's our Pandu today, not the minion. All right. So, this Popeye is very weak. He's very tired. He is low on energy. So, you need to give him some energy. Just like I get my energy from your love and support that you show through your likes and comments and the subscriptions that you give me. Yes, guys. Similarly, Popeye is going to get all his energy from Vada Pav. Okay, this is an Indian Popeye. All right. So, he is going to eat Vada Pav. Vada Pav has some calories, isn't it? It has some calories in it, like everything that you drink or eat has some calories. And so that is the heat which he is going to absorb. So those calories is what his digestive system, that system is going to absorb. And then Popeye is going to show his strength, guys. He's going to do some work and he's also going to get some internal energy. So that's our first law. Believe it or not. Yes, the heat which is absorbed or released by a system goes in two things. Number one, Popeye has got some change in the internal energy and he will be doing some work. He will be running, he will be jogging, God knows what. And that is W. So Q is delta U plus W. That's your first law of thermodynamics, which is based on energy conservation. I hope this is clear. In chemistry, this W goes there. That's the only change. I hope that's also clear. So keep in mind, physics section will be solved using this formula. Chemistry section will be solved using this work taken over that side. That's the only change because the definition of work is different. Alrighty. Excellent, guys. Let's get going to the next part. Yo, let's go. Cool. Here's the first question. There is a system which goes from state A to state B via two processes. Process 1, process 2. Okay. As shown in the figure, delta U1, delta U2, work 1, work 2, Q1, Q2 are the respective changes in internal energy, heat and work. Question is compare them. Which symbol will you put? More than, less than, equal to, whatever between these two things. Come on, think about it. Oh, what happened to SP? Who is SP, by the way? I cannot see SP, at least in the chats. Come on. All right. Oh, Science Priya. Okay. What happened to you, Science Priya? Okay. Oh my God. Already she has a nickname and for that nickname you guys gave a nickname. Interesting. Okay, some of you are saying less than, equal to, internal energies. Oh my God, high fever. I hope you got yourself checked and I hope you're fine now. Science Priya, I hoping that everything is under control. All right. So let's have a look. Hello Ankit, welcome, join in. Hello Grades Gokul. Hello Devika. Okay, let's see what should be the correct answer. Guys, think about it. Okay, from here to here, though their paths are different, just like two twin brothers might take two different paths, but they end up at the same point. So their changes in the internal energy is the same. Internal energy only depends on, keep this in mind, internal energy. Okay, depends only on the state of the gas or the system. So since the initial and final states are same, so delta U must be same. Understand, because it depends only on the state, and the state which is final is same, and the state which is initial is also same, so doesn't really matter. Okay, so that is for this one. Next, work depends on the area. So guys, obviously you can see this over here. If you draw the graphs, and graphs are already drawn, sorry, if you draw the area, my bad, so if you draw the area under graph 1 and if you draw the area under graph 2, you can check whose area is more. Whose area is more, 1 or 2? Obviously 2's area is more, so hence there will be a more than, or sorry, less than symbol over here, and that is because work depends on area under the graph. Next up, think about it. Okay, for Q, what will we do? Q is delta U plus W. Use this first law, delta U plus W. That is your first law, guys. Now think about it, delta U is same, so that means the first term is same, so whosoever has more work will also have more Q. So this relationship will be like this. This is according to first law. I hope now it's clear. Excelente! So Ankit, in that video which I uploaded, Ek Chutki Sindoor Ki Keemat Tum Kya Janoge, that one, in that there is a link. So just join over there, or if you are in pro subscription, then the course is for free. Just search for IE Irodov. Okay, just go to enroll more. When you open the dashboard, you will say enroll more option, and over there you will be able to see that. Acha, book link. Okay, fine. I'll put the book link also. No problem. I'll put the book link. Don't worry. I'll do that. Cool. All right. Let's get going to the next question. Yes, this is the correct answer. Here is the next question which was asked in 2019. A gas can be taken from A to B, all right, via two different processes, ACB and ADB. All right. Via path ACB, 60 joules flows inside the system and 30 joules of work is done by the system. Keep this in mind. If path ADB is used, then the work done by the system is 10 joules. How much is the heat flow into the system via path ADB? That's the question. Let's try and solve this. Now, these kind of questions can often lead to a lot of confusion. So you need to do it systematically. And let's do this systematically. It's not that difficult. Let me tell you that. Okay. So what I'm going to do is I'm going to make a small table. Okay. And that's it. All right. A small table of sorts, and I'm going to fill this up with ACB over here and ADB over here. Okay, and I'm going to put work, I'm going to put delta U, and I'm going to put Q as well over here. Remember, the sum of them, all right, is nothing but Q. That's first law. Okay, now just fill this table up. Things will be very simple, trust me. See what and all you know. Okay, 60 joules of heat, okay, is used from ACB. Acha, from ACB, Q is 60 joules. So put up 60 joules over here. Plus 60 because heat is going inside that system. Okay, and 30 joules of work is done by the system. So work done by the system is plus 30. Okay, if this is plus 30, think about it, how much will be delta U, guys? Because their sum must be, how much? Their sum must be 60. So hence, this is going to be plus 30. I hope this is clear. Now, think about it. Because their initial and final states for both the processes are same. If you go via this path or via that path, remember, their starting position was same, final position was same. That means delta U must be same, just like the previous problem. So hence, this will be also plus 30 joules. I hope this is clear. So both processes have the same delta U because their paths are different, but doesn't matter. Their initial states, starting states are same, ending states are also same. Okay. Now, if that is also clear, think about it. What else is known? Via ADB, the work done is 10 joules. Okay, this is 10 joules. Now think about it. If this is 10, how much will this Q be? Obviously, won't it be 40 joules, guys? So plus 40 joules, that should be the answer. Yes. Did you understand? Making this table has helped a lot, and believe me, this is the trick which nobody tells you for solving thermodynamic problems. Make this table whenever there is a confusion. Draw pressure volume graphs if needed. Okay, when you make this table, it's like solving a Sudoku puzzle. Oh, this is known, this is known, this is not known, this is not known, this plus this should be this. Just use some common sense and first law and other stuff, you will get the answer. Alrighty, let's get going to the next question. So the answer was 40 joules, that's correct. So Sakti, you can find the Irodov course on Pro subscription. So if you're a Pro subscription user, you can just search for it in the dashboard, you will get it. One option. Second option, remember a video has been uploaded just few days back. So in that description box, there is a course link. So if you want, you can buy it from there. All right. If you're a Pro user, it's for free. All right, Sakti? Cool. For crash course, it's not there. For Pro users, it is free. Crash course is only crash course. So when you're a Pro user, you get everything, be it micro course, be it Irodo course, be it KVPY course, be it test discussion, everything is there. In crash course, only things related to crash course are there. All right, cool. Let's see how many of you get this. If ice at 0 degrees Celsius melts into water kept in open surroundings, then what would be the signs for each of the quantities below for the processes of melting? Let's see how many of you get this. Kirito says minus, plus, plus. All right, I'm not sure. Let's see. Let's see. Hi Ruma, welcome, join in. I guess you are a new member. Sri Vishaka and all those students who have many more doubts, guys, trust me. If you put all your doubts after the video ends in the comments, not in the live box, I reply to every comment that you post, and you would have seen that even in the previous videos. So do that, and worst case, you can ping me on my Instagram handle. And what's that? Shreyas_Vedantu. That link is also there in the description box even right now. So either you can ping me on Instagram or leave a comment below on this video. I'll definitely reply. Okay. So Abhishek R, I'll be doing problems. What sums as in like all the problems related to 11th standard. All right, 11th standard problems I'll be doing. Yes. All right, minus, 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 minus. Delta U is plus, that's what Dinesh says. All righty. Come on, come on, come on, come on. Minus, plus, plus. Okay. So let me tell you what is the final answer. Now, obviously, when it melts, it has to absorb heat. So Q will be absorbed. So because it absorbing heat, Q should be positive. That is like obvious now. Next, think about it. What about work done? Now here is the catch. Remember, density of ice is less than density of water. Isn't that true? Because ice floats on water. If density is less, volume is more. So volume of ice for the same mass is more than the volume of water. Now what happened? The ice melts into water. So what has happened to the volume? Has it increased or has it decreased? Hasn't it decreased, guys? Ice to water, volume has decreased. So isn't there a contraction? Isn't there a contraction in the system? It has got compressed. What does it mean? Work done will be negative. Yes. So work done will be negative. Keep this in mind. Yes, correcto. Now, next up, delta U. Now, please understand this is not a gas. Lot of people might think, sir, I can use NCV delta T. Delta T will be 0. Wrong. This formula is only applicable for ideal gases. This is not a gas, it's a solid to liquid conversion. So please do not use this formula. Then you will be like, sir, what do I do then? Very simple. See guys, this has potential as well as kinetic energy. Correct? This ice had, understand, some potential and kinetic energy. Now, when this ice converts into water, think about it, will the Kinetic energy change, potential energy change, none of them will change, or only one of them will change? I feel that kinetic energy will remain the same because temperature is still 0 degrees Celsius. Yes, the kinetic energy will remain the same because the temperature is still 0 when it just melts. But potential energy, nah, it will increase for sure. Why? Because bonds are broken. That's very important. Bonds are broken. Solid bonds get broken to convert into liquids. Yes, so effectively if you see, their total sum has increased. So hence it would be plus because it has increased. That has totally increased. So delta U is positive. That's the correct answer. A lot of people get this as 0 and some people write this as plus. So be careful. I hope this is fine. Everyone understood this? Cool. Shall we go ahead? Interesting problem, isn't it? And these kind of questions have come in JEE Advanced Mains BitSat. Alright, no problem, Princey. Happens. Okay, so that's the answer. Any guesses? What's the next thing that we are going to talk about? Any guesses? What's the next thing we are going to talk about? Yo, come on, minions. What are we going to talk about next? Clearo. Good, Vyalini. Come on. Thermodynamics. Well, cyclic process. There you go, Aishwarya. Very good. Yes. So we're going to talk about cyclic process. Yes. So what is a cyclic process? A process which undergoes some series of expansions, contractions, heat absorption, heat release, work done, work is done by the system, work is done on the system, and some things like that, and eventually it comes back to the same state, and again the process repeats itself. So the process keeps repeating itself in some sequential order. For example, the gas which is there inside the engine of your car or your bike or any other such stuff. All right, even refrigerator, gas is absorbed, a lot of cycles go on, and the same process continues again and again. So that's an example of cyclic process. Now in a cyclic process, because you start from a state and come back to some original state, what happens is delta U for cyclic process is always going to be 0. Keep this in mind, because you are coming back to the same state. All right, that means Q, which was work plus delta U, will be only work as delta U is 0. Keep this also in mind. So Q is always the work, sign wise also, magnitude wise also, and delta U is always 0. Now another important thing which I'm going to give you is this. If you have a graph of pressure versus volume, guys, and let's say for example that cyclic process is something like this, the arrow marks are like this, you can see it is clockwise. Do you see? It's clockwise. Then the area enclosed inside this area, all right, is going to be positive, and that area is going to be the work done in that complete cycle. Please understand, the total work is not 0 in cyclic. It is there, and it depends on the area which is enclosed. I hope this is fine. Next up, if that graph is anti-clockwise and then you calculate that area, all right, that area is negative, and that is also going to give you the work, obviously, but that will be negative work. Keep this in mind. The sign conventions are completely opposite in chemistry. I know clockwise was negative in chemistry, but in physics clockwise is positive. My goodness. So my advice is either remember physics or remember chemistry, and remember that the other one is exactly opposite of the other subject. That's all. Yes. Any closed curve in PV graph is a cyclic process? Yes, Kirito. Yes. Any graph like this, closed curve, will be a cyclic process. Yes. Very good, very good. Yes, Akshay Kumar meme. Danush, why don't you send me here on Instagram? In fact, I have a brilliant meme which I can think of, and I'll post it up tomorrow or day after tomorrow on my Instagram account. All right. Cool. Let's get going to the next question. Now, here it is, 2019 question. Let's see how many of you can think about it. there is a sample of an ideal gas which is taken through a cyclic process ABCA as shown. The change in internal energy along CA is minus 180 and the gas absorbs 250 along the path AB and 60 along the path BC. My God, crazy stuff, I'm telling you. Work done by the, done by the gas along the path ABC is how much? Ankit, only internal energy change is 0 in a cyclic process. Okay. Is it mine, sir? I'm not sure. I'm not sure exactly what you said. All right. Vignesh, oh my God, you are new to live classes. Welcome, Vignesh. So feel free to ask any questions and also mingle around with all your friends out here. We call ourselves minions and we enthusiasts. So any doubt that you still encounter, you can always leave it in the comment section below after the video ends. And also you can ping me on Instagram for asking more doubts. Oh, is that meme yours? Sakti, I didn't see your meme on thermodynamics. If you have made, please let me know. Okay. Cool. Let's solve this problem. I don't want, why I don't want to see the options. All right. So let's solve this. Okay. So I'm going to make a table again. Okay, just like before. And I'm going to have three things: Q, delta U, and work. Okay. Remember, delta U plus W is equal to Q, and it's exactly going to be like solving a Sudoku puzzle. AB, then you have BC, and then you have CA, and then I'll put another line and I'll say total, or I can say it's for this complete cycle. Okay, then just create some divisions. Okay, now let's start filling this up. What and all do I know from this? The internal energy of the gas along the path is minus 180. Delta U along that path, which is CA. So C2A is minus 180. Internal energy of the gas, which is changed. Okay. Next, it absorbs 250 along the path AB. Okay. Along path AB, it absorbs a heat of 250. So 250 is here. Great. And 60 joules along the path BC. So BC is over here and it absorbs 60 joules over here. Okay. Now, if this much is done, don't worry even if you guys are slow. That's why you are attending my classes, guys. Trust me. Observe how I solve. Please understand, I'm not going to think that, oh, this guy answers really fast, so he's a very good student. No, I'm not going to think that, because I know you guys are going to make mistakes. It's fine, perfectly fine, guys. And even if you just listen, and even if you generally chat, it's okay, no problem. You don't have to answer correctly every time. It's okay, happens. Now, the thing is, from B to C, there is a very interesting thing happening. Do you see the volume is constant? Volume did not change. Remember, when volume increases, positive work. When volume decreases, negative work. When volume doesn't change, what is the area? 0. It's isochoric. So, in fact, the work done from B to C will be 0. Now, if this is 0, think about it. 60 is this plus this, right? So think about it. It's like solving your puzzle, Sudoku kind of puzzle. So this must be 60, because 60 plus 0 should give you 60. Oh, also one more thing. If I add all the delta U's, the total sum must be 0. Why? Remember, net change in a cyclic process, delta U must be 0. So if this is 60, this is minus 180. How much should this be? 120. Isn't that right? If this is 120, and this is 250, what plus 120 will give you 250, guys? Isn't it going to be 130 joules? Isn't that right? And what has been asked? What is the work done by the gas along the path ABC? ABC, that means ABC, A to B, B to C. So that is basically this much. This is the final answer, 130 plus 0, which is going to be 130 joules. Isn't that I hope this is clear. No, that's not the right way, Kirito. Just adding all the values. No. That's the correct way. You have to go systematically. That was just coincidence. So, did you see how we solve the questions? Logically, alright, we have made a table and this is your trick for solving many questions of this chapter. Yes. So, Bhargav, understand this is one shot of thermodynamics, not one shot of entire thing. So, one shot we did one shot of heat transfer, we did one shot of, calorimetry and stuff like that. So this is one shot of thermodynamics. I hope that's fine. Okay, yes, this is like Sudoku method. Keep this in mind. So that's the answer. Let's get going. Now, we are going to talk about all the different kinds of processes. Alright. So, Ankit, more than Menti, we are going to do mock tests because the JEE examination is very close by. Just 1 second. Yes, so why work is 0 for CA? Yogesh, because the work done is 0 because it's an isochoric process. Isochoric process. Manoj, you can check the name of the chapter down in the video which you are watching. This is thermodynamics. I hope, Yogesh, that's fine. Yes. Now we are going to talk about different processes like isothermal, isobaric, isochoric, etc. Now, the first process that I want to talk about is basically isothermal. Somebody was there at the door, that's why I had to go out. All right. So, no, I'm not making tea for you. I wish I could do that. I mean, we could have a nice tea party and some nice snacks, samosas, pakodas, and a lot of stuff. Yes, vada pavs too. So, let's talk about isothermal process. In isothermal process, volume can change, pressure can change, but temperature does not change. That's the key part. So the temperature is maintained, and keep in mind the temperature is maintained by either heating it or cooling it. So let's say you expand the gas. If you expand, usually it will cool. To prevent it from cooling, you heat it so that the temperature of the gas is maintained. Keep this in mind. And that's how the pressure versus volume graph changes. Alright. So now these graphs are very important for you guys to remember. Pressure versus volume graph. This is how it looks like. Alright. And this is nothing but a hyperbola. This is a hyperbola. And remember, since temperature was constant, so the graph of pressure versus temperature or volume versus temperature will be straight lines like this. Now, remember, since temperature is constant in isothermal process, remember pressure into volume will also be a constant. Keep this in mind. Next up, in isothermal process, what is the work done? The work done is given by nRT log to the base E, that is final volume by initial volume. There is no minus. In chemistry, there is a minus. Remember, here the conventions are different. Keep this in mind. Next up, alright, Q. Q will be nothing but, alright. Now, for finding out Q, here is the logic that I'll use. Remember, delta U will be 0. Why is delta U 0? Because temperature is constant. Since temperature is constant. And therefore, Q, which is the sum of both of them, will be just equal to the work done. Keep this in mind. I hope this is clear. Very good, Manoj. Very good. Very good. Kya baat hai? Him having Maggie, my God, making all of us jealous. Kya baat hai? All right. So, next up is, remember all these things in mind. I hope you also are making notes, and you'll also get the complete notes of all the chapters like I promised in something called as extracts. Yes, extracts will be shared with you soon. So join the Telegram group to get all these extracts. Next up, you can see there is a block kept on that piston, and that block is lifted up. That means the pressure from the top is constant. The weight is not changing, so the pressure is not changing. So this is a good example of isobaric process, when the pressure remains constant, yet the volume can change because you either heat it or you cool it. temperature can change, and that's why the graph will look like this. Pressure will be constant, volume can change, temperature can change. So these are the graphs of pressure versus volume, pressure versus temperature, and volume versus temperature. Excuse me, sorry. Now think about it. When isobaric process is going to happen, pressure is going to be constant, so volume by temperature will be constant by ideal gas law equation. I hope this is fine. All right, keep making notes, guys. Yes, very important. Next up is how much is the heat supplied, etc. Heat supplied will be NCP delta T. All right, NC for constant pressure, delta T. Then what about work? Work will be just P delta V, because pressure is constant. So when you do the integration, pressure comes outside, integration of dV will be delta V. Okay, and lastly delta U for every process is NCV delta T. This is where a lot of people make mistake. They think, oh, it's isobaric, so this should be CP. Nah, what did I tell you? For every process, delta U is same. NCV delta T, NCV delta T. It does not depend on the process. It's a state function. Remember that. Q will depend on the process. If it's isobaric, it will be P. If it's isochoric, it will be V, etc. So keep this in mind. All important pointers out here. Okay, cool. Let's get going. Yes. Now, next up, if you have made notes, next up, you can see the volume is constant, and if you heat it or cool it, you know the temperature will change, pressure will change, volume is kept constant by making sure that the cylinder does not expand or contract. That's the next process, isovolumetric process or isochoric process, whatever you want to call it. You can see in these processes volume is constant. You can see volume versus temperature, volume is constant, pressure versus volume, volume is constant. But pressure and temperature, they are linearly related to each other. So for isochoric process, volume is constant and pressure by temperature is also a constant. So what and all will be 0 and what and all will be having some value. So work done 0. Why? Because no volume change. Remember, volume is constant. What is the area under the graph? 0. Didn't we just solve a problem based on this? So work is 0. Keep this in mind. Next up, delta U. Remember, delta U is same for all the processes. So it will be NCV delta T. Next up, Q. What kind of process is this? Isochoric. So it will be NCV delta T. And first law also works. Q is delta U plus work. Check this out. 0 plus NCV delta T is NCV delta T. That's how in fact you get delta U's formula. Okay, very good formula. I hope this is clear. Yes, very good, very good. Oh my God, Dinesh, very bad. I mean, all right. Okay, very good, Madhaj, very good, Shweta. Welcome, join in. All the new minions out here, and all those people who are new, guys. I'm Shreyas, and I'm the master teacher for physics. And first of all, hit the subscribe button, because only then you can get all the videos and all the important updates for JEE, for all other competitive exams for free, obviously. And make sure that you promote this channel as well. All right, let's get going to the next process, and that is adiabatic process. So in adiabatic process, heat will neither come in nor go out, just like it happened in calorimeter. So heat can neither go in, heat cannot go out. So what can change? So let's say you compress it. If you compress it, you know the pressure will increase, volume will decrease, and you can see the kinetic energy, the randomness of the molecules has increased. So you can see the temperature will go up. So temperature can change, volume can change, pressure can change in an adiabatic process, but Q will be 0, guys. All right. Now let's see the graphs. Pressure versus volume graph, pressure versus temperature, volume versus temperature. All these look very similar, just that the laws which concern them are slightly different. So PV raised to gamma is constant. Remember this. And also TV raised to gamma minus 1 is constant. Just keep this in mind, where gamma is ratio of Cp by Cv, or you can just leave it like that, Cp by Cv. Remember, I've given you this. Or yeah, one more formula guys, I remember 1 plus 2 by F. Alright, where F is the degrees of freedom for that particular gas. Either ways. Next up, what is Q? Q will be 0. Keep this in mind, Q will be 0. That's adiabatic. What about work? Well, work will be, keep this in mind, very important formula which I am giving it to you. Note it down guys. Okay, work done will be P1 V1 minus P2 V2 divided by gamma minus 1. Keep this in mind. Also, since Q is 0, remember delta U will be, think about it, negative of work. Isn't that right? Because Q is 0 by first law. Delta U plus work should be 0. So hence it is negative of this, or if you don't like that, use this NCV delta T. In fact, this can be used to find work also. So if you know delta T, you can find work from this particular logic. Alright. So this is how it is. What is Z? I'm not sure what is Z. No, that is not Z, my dear friend. So this is 2. This is number 2. This is not Z. This is 2 by F. Okay? I hope that is fine. Cool, guys? Yes, very good, very good, very good, very good, very good. Amazing. Amazing, amazing. Let's get going. Okay? So now the next process that I want to talk about is basically polytropic process. Let's talk about this because many people do not know about this. Other things most of you would have heard. So let's talk about this first. But meanwhile, you can please have some water, have some snacks, and you can share what snacks you guys are having before we go ahead. We are going to discuss engines and refrigerators also today. So stay tuned, guys. Shweta, that reminds me of a joke which people crack. You know, it reminds me of my childhood. The first time when chemistry was taught, probably, I don't know, 8th standard or something. And then the chemical formula of water is taught to you, all of you. Like it is H2O. And then you go back in your house and you're like, hey, give me that glass of H2O. This just reminds me of that. Wow, Science Priya, my God, yaar. Biryani. Oh my God, please don't take the name of biryani. Yeah. And Uncharted had pizza. Oh wow, guys, I'm not supposed to have so much of food. You know, right? Why? So, crazy. You guys, you minions are making me jealous. Yalini, parota, nice. I'm guessing that's a Kerala parota because you're pronouncing it as parota and not parota. Alright. Dhanush. See, I agree with you. All right. Cool. I'll have something after my marathon session. Okay, guys, let's get going with polytropic process. Now, what is a polytropic process? A polytropic process is a process where you can represent pressure into volume raised to some real number as constant. Anything. Pressure into volume raised to 7 is constant. That is a polytropic process. Pressure by volume square, well, this is same as PV raised to minus 2. This is constant. This also works. How about root PV? Think about it. This is P raised to half into V, alright, which is same as, you know, PV square is equal to constant if you square both sides. Even this is polytropic. So all these are examples of polytropic process. So it's basically dependent on the equation. Now, if you observe carefully, you will realize one thing. If alpha is equal to 1, then think about it, PV will be constant, and that is nothing but isothermal process. Isn't that right? It's isothermal process. If alpha is equal to gamma, then PV raised to gamma is constant. Isn't that adiabatic process? You can see by just tuning that value of alpha, you can define that polytropic process to be a more specific process. In fact, these are special cases of polytropic process. And if alpha is equal to 0, well, V raised to 0 is 1. So pressure will be constant. Think about it. So pressure is constant, that is isobaric process. And you can apply your brains and think why this is true. When alpha is infinity, then volume will be constant. All right. And that is nothing but isochoric process. Keep this in mind. So you can see all the 4 special cases can be tuned by changing the value of alpha. Change the value of alpha, you can get those specific process. But remember, these are not the exhaustive list of the processes. There can be many more processes like this which do not have names, but you can just have them by just adjusting the value of alpha. So for a general process, PV raised to gamma, alpha is some constant. All right, remember this thing. Work done is P1 V1 minus P2 V2 divided by alpha minus 1 is the first thing. Next up, delta U, doesn't matter which process it is always NCV delta T. Last thing up, Q will be NCV delta T plus this thing P1 V1 minus P2 V2 divided by alpha minus 1. This is using first law. So just add both of them and you will get this. Now, if this much is understood, there is one more important thing you must know. If one draws a tangent, okay, if one draws a tangent over here, so this is nothing but a tangent, okay, and let's say those points are mentioned over here, okay. So the slope of pressure versus volume curve is also the slope of the tangent which is drawn, okay. That slope, keep this in mind, by definition will be dP by dV, rate of change of pressure with volume, dy by dx, whatever is there on y upon whatever is there on x. This is always negative alpha P by V. Keep this in mind, very important formula. It's going to be very, very useful. So the slope is negative alpha. Alpha is this number over here. Pressure by volume at that point. Keep this in mind. Very good, very good, very good. I hope this is clear. I hope this is clear. Is it understood? Very good. Wow, Manoj, potato parathas, nice, interesting. Have it with ketchup, have it with pickles. It's very nice, I know. Enjoy your day. All right, let's get going. So keep this in mind. Let's start with some problems. And for all the 12th standard aspirants who want to crack the February or the March attempt examinations of JEE Mains, we have laid out a special program, a plan for all of you. All right. So with regular mock tests, with discussions. In fact, we have planned 20 mock tests for all the 12th standard and the dropper students, so that you get adequate amount of practice of different variety of questions with live discussions. And also, just to make sure that your doubts are cleared, guys, we have a doubt solving facility inside our app. Yes, real time with our doubt experts right from morning till night. All right, that is what we are going to provide you. And also complete syllabus of 11th and 12th under rapid revision series. All right, so all the syllabus right from scratch with application, problems, conceptual clarity, all these things will happen in these classes which are live, and you can also record. It's already recorded. You can just play it whenever you want or whenever you feel like revising. And also special strategy sessions by Anand Sir, Pulkit Sir themselves, along with revision material and exclusive notes, and also handwritten notes of whatever is taught inside the class. All of this which are basically the essential ingredients for you guys to crack the JEE examination. And all of this is going to be provided in the description box below. Just check it out, open up that link, you will see all those things which are going to be provided in this particular crash course meant for all the 12th standard and the dropper students. Check it out, open the link. The course fee is usually 10,000, but on offer you get it for 8,000 rupees, flat 20% off once you use the coupon code SHCC. Do not forget to hit that coupon code before you join that crash course. That's very important. The next batch is starting on 8th of February. That's this coming Monday. So do not delay, because the more you delay, the later you join, you will be late for, the JEE advanced preparation. So make sure you clear it off in the first or second attempt and you are safe, and then you can focus all your attention on JEE advanced. Do that. All right. Check out all the links which are pasted in the description box below. All right, cool. Let's solve the next question. Here it is. Harry will do semiconductors next week. Don't worry. We are going to do everything next week. Don't worry. Shweta, you are new. Can you complete your backlogs in 11th in one shot series if you are in 11th now? Yes, Shweta. I would advise you to please check all our playlists, past videos. Believe me, I have kept it very crisp, concise, to the point, whichever is required to crack the examination. So for all 11th as well as 12th standard students, don't worry. Yes, so can you get previous year question paper? Yes, Manoj, on the official website of NTA you can get all the previous year question papers. Yes, you can do that. Hello Shailesh, welcome. All right, so okay, Yogesh, I'm not sure. It depends on the flow. Come on, guys. 2019 question. Let's see how many of you get this. Okay. Cool. So here we go. So see, guys, it's very obvious that if you go systematically, isochoric. Which one is isochoric? Think about it. Isochoric means volume must be constant. Isochoric will be D graph, because volume is constant. What is A? A will be pressure is constant. That means isobaric. So that will be A. Okay. Then isothermal and adiabatic. Now out of these two, which one is what? Remember, I just told you about the slope formula. The slope is negative alpha pressure by volume. Now think, for isothermal, alpha is 1, and for adiabatic, alright, alpha is gamma. Now whose alpha is more? For adiabatic or for isothermal? Obviously gamma is more than 1. So that means, what can you say? The slope is more negative for adiabatic. So slope of adiabatic is more negative than of isothermal. Keep this in mind. So out of C and B, think about it. All right, C will be for, all right, for isothermal, what can we do? Isothermal will be B graph, all right, and adiabatic will be nothing but C graph. That's how it goes. So DABC, which is option D. I hope that is fine now. Everybody understood? Yes, that is clear. Very good. Yes, the answer is D. Correcto. Yes. So let's get going with the next question coming up on your screen. So here it is, 2019 question. Half a mole of an ideal monoatomic gas is heated at constant pressure of 1 atm 20 degrees Celsius to 90. Work done by the gas is close to. Come on, let's see how many of you minions, starting with basic question first, and then slowly I'm going to increase the level of difficulty. Come on guys, let's do this. Here it is. So how do we do this? Guys, what kind of process is this? First think about it. This is nothing but constant pressure. That means isobaric process. Now for isobaric process, what is the work done? Isn't it P delta V? Now think about it. What is pressure? Or rather, what is P delta V? Think about it that way, because remember, PV is equal to nRT. If you use this concept, P delta V will be nothing but NR delta T. Now what is N? N is half. What is R? It is given to be 8.31, I believe. Yes, into delta T. 90 minus 20. So 90 minus 20. That's it. Solve this and you will get the answer. Is it coming out close to 291 joules? Just check this out. 291 joules approximately. And that should be the answer. Yes, very good, very good, very good. I hope this is clear. Excellent, excellent, guys. Okay, let's get going with the next part of the series, and the next question coming up on your screen, 2020 question. A liter of dry air expands adiabatically to volume of 3 liters. Gamma is given. Work done by air is how much? Let's try and solve this, guys. So, first thing that we are going to do is to find the work done in adiabatic. I need to know P1, V1, V2, P2. All these things need to be known. So what is P1? Because it is STP, so I can say approximately 10 to the power 5 pascals. Volume 1 is 1 liter. 1 liter is 10 to the power minus 3 meter cube. Then similarly, what is P2? In fact, I don't know. What is the new volume? 3 liters. So 3 into 10 to the power minus 3 meter cube. Now use P1, V1 raised to gamma is P2, V2 raised to gamma. Therefore, you will get P2 is equal to P1, which is 10 to the power 5, into V1 by V2. V1 by V2 is 10 to the power minus 3 by 3 into 10 to the power minus 3 whole raised to gamma. Gamma is 1.4, that's given. So it will be 10 to the power 5. And this thing, understand, 10 to the power minus 3, 10 to the power minus 3 goes, and 3 raised to 1.4 is already given to be 4.6555. That's what you will get P2 as. Now the only thing which is remaining is to find the work done. Work done formula, P1 V1 minus P2 V2 divided by gamma minus 1. So substitute everything. 10 to the power 5 into V1 10 to the power minus 3 minus P2 I just figured it out, 10 to the power 5 divided by 4.6555 into new volume V2 was 3 into 10 to the power minus 3, okay, divided by the whole thing divided by gamma is 1.4 minus 1. Solve this and you should get the answer. Check it out if it is close to 90 joules. Yes, it's calculative, but these kind of calculative questions also come in JEE Mains. So you need to know how to solve these kind of questions. You must be quick with calculations, divisions, multiplications, squares, square roots, everything. So this value comes out very close to 90.5 joules. Yes. So Dhanush, I'm going to conduct a special session for all the constants and all the values that one must remember for JEE Mains very soon. So stay tuned. How to do calculations? I think one lecture was already conducted by Shimon sir, faster calculations, but for physics, what are the important values and constants you must remember? I'm going to conduct a special session for that. So stay tuned, guys. Okay, so a lot of people are asking why calculators are not allowed. Believe me, calculator reduces your thinking ability, your analytical skills. Remember, calculators actually improve your brain. Yes, it triggers your brain. It keeps your brain alert, active, all right, alert. But the moment you start using calculators, even at home, believe me, you are doing a biggest mistake of life. Yes, keep this in mind. No, Ankita, I'm not. Okay, so 90.5 joules, that's the answer. 2018 question. 1 mole of an ideal monoatomic gas is compressed isothermally in a rigid vessel to double the pressure at room temperature. What is the work done on the gas? Okay, let's do this. So, first of all, important words. Is compressed isothermally. Acha. And what has been asked? Work done. What is the formula for work done in isothermal process? Recollect, nRT ln V2 by V1. But hold on, they are talking about pressure. The pressure is doubled. And here the volume is given. Now try to remember that pressure and to volume is constant for isothermal process. So basically this formula will reduce to nRT ln, alright, nRT ln P1 by P2. Because pressure into volume is constant, so V2 by V1 will be P1 by P2. Now substitute everything. What is the number of moles? 1 mole. What is R? I think all the options have R. And temperature, 27, don't put 27, put in Kelvin. So that is 300 Kelvin into ln. The pressure is doubled, so keep that in mind. So initial pressure, if it was 1, final pressure is 2. So this will become 300 R. This 2 is down, bring it up. So it will become ln2 but with a negative sign. Now one might be wondering, sir, there is no negative sign anywhere over here. Alright, so how come you got negative answer? Be careful. This work is done by the gas. Yes. And the question asked is, be careful, on the gas. Keep this in mind. So work done on the gas will be negative of this, and hence the correct answer will be this one. Okay, I hope this is clear. I hope this is clear. Very good, very good, very good. Excellent, excellent. That's why we did this question, because a lot of people got this wrong. They were scratching their heads, okay, what is wrong, something is wrong in the examination hall. All right. So this is the answer. Next question. A gas is compressed from this volume, all right, at constant pressure of so and so, and is heated by supplying this much energy, and how much is the change in internal energy? Now this is such a beautiful problem, 2014 question. Believe me, you can search this on Google and you will see a wrong solution posted by many websites. Yes, many people have posted the wrong solution of this particular question on their websites. So that is very, very important to understand how this question exactly has to be solved. So pay attention to this question because it's a beautiful question. Somebody might overlook, okay, how this has to be solved. So first of all, let's try to visualize this because it's not so easy. Remember, one thing was by tabular form, by drawing something like a Sudoku puzzle. Another trick was to actually draw the graphs to just get an idea of this. And let's do it the graphical way. It will be really easy to understand what is happening exactly. This is pressure, this is volume. Now let's see what is happening. Okay, so the gas is compressed from 2 to 1 meter cube. Acha. So at a constant pressure, that is also given of this much. So at constant pressure, I am reducing the volume. That's very important. And from 2 to 1. Okay, so that is what has happened. Cool. Now, thank you there. Welcome. Now, for the next part, it is heated at constant volume. Okay, it is heated at constant volume. Keep this in mind, by supplying so much of energy. Now, if you heat the gas at constant volume, think about it. Whatever heat you give is going to increase the temperature. It's going to increase the pressure. So obviously, it's going to go up like this. This is how it's going to go at constant volume. All right. The question is, what is the total internal energy change of the gas? If I call this as A, if I call this as B, if I call this as C, they are asked you what is the total internal energy change. Now let's see how do we do that. First of all, let's see from B to C. All right, from B to C, what and all things can we say? B to C is an isochoric. All right, it is isochoric process. And because it is isochoric process, work done is 0, right? Okay, delta U, okay, is going to be, okay, think about it. Delta U is going to be equal to Q. Isn't that right? By first law of thermodynamics, delta U is going to be Q. And what is Q? Q is already given. It is heated by supplying energy of 150 joules. Do you see that? 150 joules was supplied. So this will be 150 joules. Okay, so this is 150 joules. Okay, fine, great, keep this aside. Now from A to B, let's see what is going to happen. Now from A to B, the gas is compressed. All right, the gas is compressed by from 2 meter cube to 1 meter cube at constant pressure. Now think about it. If it is compressed, all right, if it is compressed, what is going to happen to its temperature? If the gas is compressed, and please keep this in mind that this is isobaric process. What is going to happen to the volume? Volume is going to decrease. What is going to happen to the temperature? Temperature is going to increase or decrease. Come on, think and tell me. What is going to happen to the temperature? Come on, think and tell me. If it is compressed, think about it. Think about it. At constant pressure, all right, the volume is going to decrease. Come on, guys. Think about it. Decrease or increase? Come on, think about it. Increase, some people are saying decrease. Oh my God, we have a debate right now. Come on, guys. Think about it. Think about it. Again. All right, come on. All right. So, let me tell you what is going to happen. If the volume is going to decrease, remember PV is equal to nRT, guys. PV is equal to nRT. If volume is going to decrease, even the temperature should reduce, right? So even the temperature is going to reduce. Now if temperature is going to reduce, think about it. What will happen to delta U? What will happen to delta U, guys? Yes. What will happen to delta U? Will delta U be positive or negative? Will delta U be positive or negative? Think about it. It will be negative. Yes, it's going to be negative because temperature has come down. Now, the question is, what is the change in the internal energy of the gas? Now, the problem is, how do you calculate this delta U from A to B? Do you know that? No, because for that calculation, I need NCV delta T. All right, I need NCV delta T. And the problem is, I do not know the value of moles. I do not know the value of CV. I do not know the value of delta T. That's a big problem. Now, how do you do this? How do you do this? Because you want to calculate the total internal energy change. How do you do this problem? Think about it. Think about it. How are you going to do this? Do you see that there is missing information over here? Do you see that there is missing piece of information out here? Yes, there is missing piece of information out here. So delta U for this part, was there, but delta U for this part is not there. That's the strange part. And how do you calculate it? Because even from that compression part, all right, volume change, you can only calculate the work, but you cannot calculate, all right, you cannot calculate. Yes, see, even if I do this, for example, even if I do this from, what is that, A to B, okay, from A to B, if I calculate what is the work done, work done is P is 100, and final volume is 1, initial volume is 2, so it is going to be minus 100 joules. Now delta U, okay, how do I calculate delta U? Think about it, because Q is equal to delta U plus work done, so delta U is Q minus W, so therefore it's going to be Q minus of minus 100, which is going to be Q plus 100. Isn't that correct? Isn't that correct? Now think about it, guys. Think about it. What will happen now? Can we find out Q? Can we find out Q somehow? Because for finding out Q, again I need NCP delta T. How do you find that out? That's the problem. Yes, big bounty on delta U. That is the problem. So there is that missing piece of information, and all right, that clarity is not there. That's why this question was given. Keep this in mind. Okay, so please understand, lot of books and lot of people, what they have done, I'll tell you, they have just found out the work. All right, that work done, they have found it out as -100 or something. Okay, and somehow magically they have also found out delta U. Okay, I don't know, they have just added these two numbers and they have written 250 or something, and they have just given the answer. Does it even make sense, guys? These two numbers, just adding it randomly and getting the answer? I don't think so. So a lot of books have given this answer, but please understand this is wrong. No, please. Okay, cool, let's get going. So yes, now let's get going to the next one. Here is the next 2020 question. Which of the following is an equivalent cyclic process corresponding to the thermodynamic cycle? Okay, so these kind of questions are also very common and you should know how to solve them. There will be a graph given. They will ask you which is the corresponding graph which is most suitable for this. Okay, let's see how do we do this. Think. 1 to 2, this is adiabatic, cool. 3 to 1, what is it? Volume is constant, that means it is isochoric. Okay, 2 to 3, what is it? Isobaric. Question. All right, now think about it. Which of these graphs match with this scenario? I feel that 2 to 1 is adiabatic. Guys, how can this be a straight line? This cannot be a straight line. All right, please keep this in mind. This is a line. This is definitely not allowed. For volume versus temperature, for adiabatic, it has to be curve, gone. 2 to 3 is isochoric. Guys, 2 to 3 is isobaric over here. Check this out. So pressure must be constant. Can you see in this graph? If pressure has to be constant, it has to be a straight line. How is it a curve? It's a curve. This should not be a curve. This is wrong. You can see that. At least check one part which is wrong in each graph. That will give you the answer. And similarly over here, 3 to 1 is isobaric. 3 to 1 is isobaric. How is it a curve? It's a curve, guys. This is also wrong. For isobaric process from, oh sorry, my bad. 3 to 1 is isochoric, so sorry. And over here, 3 to 1, it's not even isochoric. Come on, volume is not constant. How is this? How is this possible? Because 3 to 1 was isochoric process. So the only option left over here is option C, guys. This should be the correct answer and you can check it out. Yes. Very good, very good. A lot of minions have answered it. Excelente, excelente. That's the correct answer. Very beautiful question again in 2014. Let's see how to solve this. Looks scary, but trust me, it's not. Okay, the equation of a gas is very weird. nRT plus alpha V. Some weird gas it is, okay. N is moles, alpha is some constant. Initial temperature and pressure are T0, P0. What is the work done by the gas when the temperature is doubled isobarically? Okay, what is the work done? Alrighty, let's see how do we solve this. What is the formula? What is the formula for work done? Work done for isobaric process. Keep this in mind. Work done. Okay, because that's the question. Work done. Work done formula is P delta V. Okay, that means I need delta V. So here is what I can do. All right, from this equation, P V is equal to nRT plus alpha V. What I can do, I can write PV2, all right, is equal to nRT2 plus alpha V2, and PV1 is nRT1 plus alpha V1. Now, if you subtract both of them, because P was constant, N is constant, R is constant, alpha is a constant, what will you get? P V2 minus V1 delta V is equal to nR T2 minus T1 delta T plus V2 minus V1 is delta V. This is what I will get. Now, take delta V on one side. So delta V will be equal to, we'll do one thing. Delta V is equal to NR. Okay. So delta V, I can take it common over here, and P minus alpha is equal to NR delta T. Okay. So therefore, delta V is equal to NR delta T divided by P minus alpha. Now substitute the values. What is the moles? 1 mole. Okay, so N is 1, R is R. Temperature is doubled, be careful. So delta T will be 2 T naught minus T naught, which is just T naught. Correct? So this will be just T naught divided by pressure. What is the pressure? It's isobaric process. Pressure will be constant. Keep this in mind. So it will be constant, P naught minus alpha. Great. So the only thing left now is to find the work, and work is pressure delta V. Pressure is P naught. Delta V is this value. So R T naught divided by P naught minus alpha. And is it matching with any of these options? Yes, I believe it is. And that is the correct answer. I hope this is clear. This is the correct answer. Yay, very good, uncharted. Jinesh, VK, Kamlesh. I am Candida, Pep, Gamers. Yes, yo, correcto. Excelente. Weird question, but look at the solution. So interesting and so involving, I must say. Yes, that's the beauty of this question. Now, let's talk about engines. We have come to the final part, guys. Get ready. Yes, let's do this. Let me also drink some water. My God. My God, VK, what is the pain? So Jinesh, I used to teach in this JEE B batch, but now all the batches are over. So I'm conducting lots and lots of classes, chotu, small courses like Erodo course and that course and this course and all that. Okay, cool. Now let's talk about engines. Yes, Ankit, I do know. Now, in engines, what exactly does an engine do? The job of an engine is very simple, and understand this because after listening to me for the next 15-20 minutes, you will be able to solve all questions on engines, refrigerator, etc. and that too conceptually. That is very important. So look at this animation, you will understand. This is a hot reservoir. This is a cold reservoir. What is the meaning of reservoir? Reservoir is a very large body which can supply or take heat, and the temperature does not change much. So yeah, because it's so huge, even if it absorbs or releases some heat, there is hardly any change in the temperature. So that's the meaning of a reservoir. This is a hot reservoir. This is a cold reservoir. Now obviously heat will always flow from hot to cold. Isn't that correct? But we trick it a little bit, and as the heat goes from hot to cold reservoir, we extract some work. You can see this piston cylinder arrangement. Look at this, the piston is down, the heat gets extracted, the gas expands. As the gas expands, it does some work. Alright, some work is done. Now you need to get back that piston down here. So you give back that heat, alright, to the cold reservoir. And again, you take that heat, again that gas does some work. Alright, when that work is done, again when that work is done, again you bring it back and give that heat back to the cold reservoir. And this process continues. That's the job of an engine, and that's what every engine in an automobile, in a train, in an aeroplane, in a ship, etc. everything exactly does this. That's the job of an engine. I hope this is clear. Now, this is the block diagram of an engine. What is this? Hot reservoir. What is this? Cold reservoir. What is this QH? Heat absorbed from the hot reservoir. Out of that heat, some amount is used to do work, and some amount is given back to the cold reservoir. That is what is happening in this block diagram. This is the engine. The engine absorbs the heat from the hot reservoir, does some work, and some heat is rejected to the cold reservoir, that is surroundings. King T, Faisal, TM, don't spam, I will not respond to that, okay? So don't bother. Alright, so here it is. Now, if you apply energy conservation, what you are going to see is QH, which is the energy which is absorbed from the hot reservoir, will be equal to the work done plus the heat which is given to the cold reservoir. So this is hot reservoir, this is the cold reservoir. I hope this is clear. I hope this is clear. Yes, yes, yes. Now, if this much is understood, think about it. What is the meaning of efficiency of this engine? Yes, how efficient this engine is. Efficiency, the symbol for that is eta, is what you want upon what you give. Everything you want around you to be more efficient. That means you want to give very little things, but you want it to do a lot of things as a result of that. Now, the thing is, what do you want out of an engine, guys? You want it to do work. So work is what you want, and what are you going to give it? You're going to supply it some heat by burning that petrol, by burning some fuel and stuff like that. So QH is what you're going to give it. So output by input, that is the efficiency. But if you want it in percentage, multiplied by 100. So if it is in percentage, just multiply it by 100. I hope this is clear. Yes, correcto, excelente, excelente. King TM, post your doubt after the lecture in the comment box. I will respond, but not now. Okay, cool. Now, last part over here. Last part which is over here. Let's talk about this. Okay, very good. Now you have understood the block diagram of an engine. Now, you will be like, sir, I want to make this engine very efficient. Tell me what to do. So there was a guy named Carnot, and he tried different variations of different cycles, and he found that there is one particular cycle which gives you the highest efficiency. But I'll tell you the bad news. The bad news is that efficiency is not 100%. No matter what you do, no matter if the sky meets the sea or ocean anywhere, no, it's not possible. You cannot get 100% efficiency. The maximum efficiency that you can get is for a Carnot engine, and that's a specific cycle: adiabatic, isothermal, adiabatic, isothermal. If an engine undergoes those four processes, only then the efficiency is highest. Otherwise it is not, and that efficiency, which is the Carnot's maximum efficiency, was found out to be 1 minus the cold temperature by hot temperature, which is also 1 minus QC by QH. Okay, so keep this in mind. So this is the efficiency of a Carnot engine, which is the maximum possible efficiency. You cannot have efficiencies more than that. This is not required so much, but you will need this. Keep this in mind. Okay, cool. Yes, nothing is ideal. Amazing go. Let's solve this 2020 question. Beautiful question. Let's see how many of you can do this. There is an engine and it is involved with exchange of heat of 1915 minus 40 125 minus Q during one cycle, and it achieves an efficiency of 50%. So the question is, what is the value of Q? Interesting question. Let's try and solve this. First of all, let's visualize this question. That's better. Okay, let's try to think what exactly is happening. This is my engine, guys. Okay, it's going to do some work. Also, it's going to absorb some energy, and it is also going to reject some energy. It's going to absorb a lot of energy, keep in mind, and it's going to do some work, and it's going to reject some heat. First of all, what and all did it absorb? 1915, yes, it absorbed. Minus 40, that was rejected. Okay, plus 125 also absorbed. Minus Q also rejected. So 40 plus Q is basically rejected heat. this was rejected or given to the cold temperature. This was nothing but absorbed heat. I hope this is clear. Now try to solve the problem. Think about it. Think about it, guys. The efficiency formula is work divided by heat which is absorbed. Output by input. Efficiency is 50%, that means it is half. Isn't that right? Everybody getting it? And what is the work done? Well. The work done will be this minus this. Keep this in mind. This is absorbed, some is rejected. The work will be whatever is absorbed, 1915 plus 125 minus 40 minus Q. Isn't that correct? That is the work. And how much is absorbed? 1915 plus 125. Check this out. This is what is going to happen. Now, if you do the math, 1915 plus 125, guys, come on, 1915 plus 125, how much is it? Think about it. 25 plus 15, 40. Yes. So it will become, yes, 2040 is equal to minus 2000. Okay, so this will be 2000 minus Q into 2. That's what I'm going to get. And now just do the math. This is going to be 4000 minus 2Q, I believe. So therefore 2Q will be 4000 minus 2400. Just check this out. So it's going to be 1960, I believe. So Q will be equal to, check this out. It's going to be 980. Familiar number. So that's the answer. 980 joules. Very good. Yes. I hope this is clear. I hope this is clear. Amazing. Amazing. Oh my God, who is this fruit fly? Pep Games. I hope it loads really fast because we need to be a little bit quick. Okay. Cool. Got it? Guys, if you study under me, if you study everything in detail under me, trust me, nobody is going to stop you from cracking the examination. Believe me, many students have not done it like a joke. Students have cleared under me lot of years. You can also do it. Just have faith, patience, perseverance, consistency. You are going to do it. Let's get going to the next question. But before that, what is a refrigerator? I'll tell you what is a refrigerator. Exactly opposite of whatever a engine is. Yes, exactly opposite, guys. So you can see the block diagram. This is a fridge. This is the cold. This is the hot side. Now you might be like, okay, what exactly is what? This is the colder one. This is the hotter one. So let me tell you what happens in a fridge. So in a fridge, there is a compressor and stuff like that. Okay, so you might have things inside it. I don't know, maybe what do you want to keep inside a fridge? Can you tell me? Okay, maybe a cold drink. Okay, so there's a cold drink. And maybe, I don't know, you want to keep gulab jamuns, all right? Oh my God, this reminds me of that day, guys. You know which day, right? And I had a lot of gulab jamuns. All of this is in the fridge. Oops, I feel like opening the fridge. Anyways, and this is your engine or whatever, that motor which is going to do some work. And this is your surrounding. The surrounding, okay? Now the surroundings are going to be hot. Keep this in mind. The inside part is going to be cold. Now, where will heat flow in a refrigerator? Answer this $1 million question. Where does heat flow in a refrigerator? From inside to outside or outside to inside? Come on, $1 million question. What does the compressor, that motor which is there, what does it do? Where does it make the heat flow from? From inside to out or outside to in? Oh my God, come on. Think about it. All right, outside to inside, inside to outside, surroundings. Well, let me tell you, you might be thinking outside is hot, inside is cold. So heat will go from hot to cold. Wrong, my dear friends. Wrong, completely wrong. The heat is going to flow from in to out, from cold to hot. This is so unnatural. Heat usually flows from hot to cold. Suddenly over here, heat is flowing from cold to hot. Like, what the hell is happening out here? My mind is shaken right now. But that's the whole point of having this compressor. If the compressor was not there, the heat is going to come from hot to cold, obviously. And whatever is there is inside, your poor gulab jamuns are going to get heated up, and you might not like it because they're going to get stale. So the thing is, the job of the compressor, that motor, is to make sure it flows unconventionally, unnaturally. It's not natural. Heat usually should go from here to here. So the compressor makes the heat go from inside, which is cold, and makes it go outside. So heat is taken from these objects, it cools it and throws it out. I hope this is clear, and that's why the outside of your fridge is warm. Isn't that correct? Oh my god, yes. But to preserve it, Dhanush, you need to keep it cold, right? Yeah, cool. So that's clear. Yes, amazingo. Amazingo. Great. So that's the job of a fridge. Now that you have understood this block diagram makes sense. This is that motor, that compressor, something which is doing work. You need to do work. It won't do work. It's not an engine. You need to do work, and it will extract that heat and it will be throwing it out. So here the logic is QH. Again, it's same. QC plus W, same equation. This plus this is that, obviously. But here you have the performance. The performance of a refrigerator, beta. What do you want upon what will you give? What do you want out of these three things? What do you want, guys? You want it to absorb a lot of heat. Yes, you want it to absorb a lot of heat. And what are you going to give? You are going to give it some work. That's the input. That's it. So that's the coefficient of performance. Amazingo. Clear? Very good. Very good. Very good. Very good. Very good. Yes. Okay, I missed. Okay. So now you'll be like, sir, which is the best performing refrigerator? Sir, is it Samsung? Is it LG? Is it Bosch? Is it Haier? Is it something else? Tell me, sir, which is the best performing refrigerator? I'll tell you which is the best performing refrigerator. So guys, the best performing refrigerator is that refrigerator, the best one. Any guesses? Best refrigerator. Who? Whirlpool, LG, none of them. My god, VK channel. My god, I'm going to hog onto something listening to your conversation. It's so tempting. LG, China wala. Carnot. Yes, Ankit. Correcto. It's Carnot. I'll be like, sir, which brand is this? New brand? No, it's not a new brand. It's very old method. It's not a brand. Okay. So Carnot cycle, that refrigerator which undergoes Carnot cycle, the one which I just showed you. Remember, just previous to previous slide, that cycle exactly in reverse will be the best refrigerator and the best performing refrigerator. And that has the maximum value as 1 by, okay, TH by TC minus 1. Everything is reverse. Look at the formulas. 1 by hot by cold minus 1. Okay, keep this in mind. Very good, very good. Yes. Nothing piece. I feel you will hardly get direct formula based questions from AC circuits. Last question for today, sorry, second last. The last question is very tricky and you will love it. The question after this. Okay, this is a second last question. A Carnot engine has efficiency so and so, is being used as a refrigerator. That means you reverse it. Okay. Work done is 10. How much amount of heat is absorbed from the reservoir at lower temperature? Let's do this. It's not that difficult. Okay, so there you go. You have your engine, and let's say this is Q1, let's say this is Q2, and let's say this is work. Cool. Now what has been given? Okay, so the efficiency has been given. Efficiency is 1 by 10. Great. Remember, efficiency was work divided by what you give. Therefore, you will get 1 by 10 is equal to work divided by Q1. Therefore, Q1 is equal to 10W. Great. Now, what are you going to do? This engine is converted into a refrigerator. Okay, so what does a refrigerator do? All these arrows are going to shift their directions, but their values are going to be the same: Q1, Q2 and W. Now it's given the work done on that refrigerator is 10 joules. So this is 10. The question is, what is the amount of heat absorbed from the lower reservoir? So basically they are asking Q2 is equal to question mark. Acha, this is not that difficult. See, from this equation, I will get Q1. How much is Q1? 10 times of W. W is 10, that's going to be 100. Great. Oh, one more thing. This Q1 is also equal to Q2 plus W. Isn't that right? By energy conservation. So Q1 is 100, Q2 I don't know, work is 10. That gives me Q2 is how much, guys? 90 joules. That's the final answer. 90 joules. Is that clear? Hello Pranav. Yes. Engineer is a reverse refrigerator. Good one, Kirito. All right. Super confusing, but we have solved it in a very crystal clear manner. All I have done is use block diagrams. So now the trick for solving refrigerator and engine questions: draw block diagrams and solve it. Remembering those block diagrams, you will never get confused. Very important. You have seen so many tricks today, guys, for solving questions on thermodynamics. Sudoku trick for thermodynamics. Then I have told you graphical trick for thermodynamics questions, and then block diagram trick for solving engine and refrigerator questions. Now this question: what will happen to the room if you leave the door of a refrigerator? I mean, that will be really cheap. I mean, somebody who does not have AC might have tried this. Oh, I don't have a AC, I know what to do. I'm going to keep the door of the fridge open and let's see what's going to happen. Have you tried this? Well, if you haven't, please try it and let me know what happens. By the way, I have posted the answer on Instagram. Check this video out. Yes, if you haven't, please do that. Hey, come on guys, check this video. Who is this dude? Who is this superstar? I don't know. Somebody's, oh, look at this. He looks like Shah Rukh Khan. Is he SRK? Who is this? Who is he? I'm not sure. He looks like a superstar to me. All right, cool. So do that. Check his video out. He has explained it very well, and you can definitely post comments on that as well. All right, cool. Yes, and do try it at home. Well, I know some of you think that this is some chemistry stuff which I'm going to ask you to do at home. No, it's physics stuff. So these are the two problems. This is the first question. You have to figure out which graph matches. Answer has been posted. Do not see it now. Okay. This is the second question. Options are there. Do not worry. It's a very simple question, but you have to solve it systematically. Solution has been posted here. You can check it out later on. And do join our Telegram group for getting all the important updates, notifications, and all the important PDFs and session links and all that stuff. All right. Oops, Princey, thank you. All right. So guys, so last few days, I know, before your JEE Mains examination. So whatever you need for the last few days, which is your obviously most awesome, amazing faculties, dedicated ones, and obviously reputed institutes like Vedantu, of course, and obviously proven track record, and also a dedicated and systematic plan for your last few weeks. All of this in this crash course which we have prepared for all of you, entire 11th and 12th syllabus, along with doubt solving, instantaneous live from morning till night, along with handwritten notes, revision notes, extra problems, assignments before the examination, also mock tests, 20 of them, and also special tips and strategy sessions by our excellent master teachers. So all of this in this crash course, all the details for this crash course, which is going to start this Monday, 8th of February. Yes, 8th of February. The usual price being 10,000, discounted by 20%. You get it for 8,000 rupees only when you use this coupon code SHCC. Remember this, by heart this, yes. And the link for joining, all the details is given in the description box below. Do check it out. I'm not sure how many of you do actually check out the description box. And yes, you know what to do. Hit the subscribe button if you have not done it yet. And also hit that like button if you have not done it yet. Smash it, guys, if you have not done it yet. If you have done it, don't do it. All right, again. Yes, that's all. Thermal physics is over. Tomorrow, a special session on mock test. Yes, the link will be posted on Telegram. Do join it now. This was Shreyas here. Bye bye, all the minions. Tada, take care. If any doubts, please post it below after the video is over. I'll definitely make it a point to respond to it. Bye bye, take care. Good night. I'm going to hog and I'm really hungry. Bye bye.